Okay, hope you enjoyed your Thanksgiving break. Now it's time to get back to a little bit of work. I'm working on related rates problems. I'm going to show you an example of one of the homework solutions, but first I wanted to just go through the main steps for solving a related rate problem. No matter the difficulty level, the steps are always the same. First thing you're going to do is write down what you know. The second thing you're going to do is write down what you need, the things that are missing that you might want to have. After you've written them down, you're going to relate the quantities, not the rates, just the quantities. Relate those together. Then you're going to derivate, or take the derivative, or differentiate, however you want to write that down. You'll then have two equations. You'll have the original equation, relating the quantities, and another equation, relating the derivatives. You will then solve for what you're looking for using both equations, both the relationship between the quantities and the relationship between the rates. So let's go back to step one for the problem that you were given, and I'm going to read it off to you. It says a point moves along a curve y equals negative 0.5x squared plus 8 in such a way that the y value is decreasing at a rate of 2 units per second. At what rate is x changing when x is equal to 4? So here's the question. What do I know? Well, they're giving me some information here. They're saying that the value of y is decreasing at a rate of 2 units per second. A rate is a derivative, so I know it must be dy dt, because everything's based on time, equals, they said 2 units per second, so I know it's 2, but they told me decreasing, so I know that's going to be a minus sign. It's going to be a minus sign. I also know that they want me to find when x is changing, when x is equal to 4. When x is equal to 4. These are two things we know. Are any of them true all the time? Yeah, this rate of this change is true, but x is going to keep changing, so I'm going to fill that in when I need it coming up. And they asked me to find what things do I need. They want me to find the rate x is changing. Rate is a derivative, so I'm looking for dx dt. So once again, they gave me dy dt at x equals to 4, and they're asking me to find dx dt. Now the nice thing about this problem is it just says relate the quantities. I'm just trying to relate x and y in some way that'll help me solve the problem. And the nice part about this is they gave me the relationship already. They gave me that y equals negative 0.5x squared plus 8. Whereas in the past I've been looking to find the relationship either with a Pythagorean formula or volume or area. They're giving it to me right here. So now that I have the equation and I have the relationship, I'm going to derivate. I'm going to derivate y equals negative 0.5x squared plus 8, and I'm derivating based on t. So anytime I see any other variable but t, I'm going to include d something dt. Derivative of y is 1 dy dt. 1 dy dt, we just don't even write the 1, equals negative x dx dt. Why negative x? Because it's 2 times 0.5. And 2 times 0.5 is obviously 1. And to the derivative of x, it becomes t. The derivative of 8, Tom Fay. Derivative of 8 goes away. Boom. So this is the relationship. I now have two relationships. I have the original equation, and I have a relationship between the rates. And the last step I'm going to do is I'm going to solve using both equations. They told me solve when x equals 4. And my derivative equation is dy dt equals negative x dx dt, and that's what it's equal to. Do I need to know y to find this rate? The answer is no, because I don't see y there. So I know dy dt. Oh, I know dy dt. Eraser, prima dollar. What was dy dt? I got to peek back to see. Forgot it already. Dy dt was negative 2. So I know negative 2. I know negative 2 is equal to negative 4 dx dt, and I can divide both sides by negative 4, and I get dx dt equals 1/2. What does that tell me? It tells me that x is increasing as y decreases, and that's the solution for the first problem.